All right, so back again, try a few more things. We're moving on to carboxylic acids. Now I tend to think about carboxylic acids as being the universal donor in terms of carboxylic acid derivatives. And that's because carboxylic acids can actually be turned directly into any carboxylic acid derivative. So they don't fall nicely into that scale of most reactive can go to next, and least reactive can't go anywhere. They can be turned into anything. So we'll talk briefly about each one of these different options. First off would be carboxylic acids being converted into acid chlorides. There are several reagents that can be used. The one we see most typically is right here, thionyl chloride. Now if we look at thionyl chloride, it looks kind of already like a strange acid chloride. And that's a good way to think about it. It's a strange acid chloride. It's got this carbonyl-like group in here. It's got actually 2 chlorine leaving groups on it. We're going to wind up donating one of those chlorines to become the chlorine in our acid chloride. Now, if we do think about this as kind of a carboxylic acid derivative, a really, really reactive one, then it starts to make sense what's going to go on in this reaction. In this reaction, we'll actually use the lone pairs on our oxygen to add into the sulfur and form something that's kind of like a tetrahedral intermediate, except that it's on sulfur, which makes it a little different. But just like we've done before, this is going to collapse back down. It's going to kick out a leaving group. Actually, chloride is our leaving group. And get us to now an intermediate that looks a bit like a weird anhydride. We've got our clear carbonyl here, and then we've got this sulfur oxygen double bond. Let me clean that up a little bit over here. And it's protonated in the middle, so that's a little different as well. But I'm illustrating this just because what we're going to see over and over is this chemistry is really the same sort of chemistry that we've seen before. So nucleophile adds into electron deficient sulfur in this case, tetrahedral intermediate, collapses down, kicks out a leaving group. And now to complete this process, we simply do the same thing all over again. We kicked out a chloride ion over here, so I can draw that in, keeping track of it. And I can use that electron density now to add into this particular carbonyl. It's actually the more reactive of the two. And at this point, I have something that looks really strange. I've got chloride. Usually think about that as a leaving group, but I've also have something that has a protonated oxygen, usually a leaving group. Well, let's pick the part that we just didn't just add. So in essence, this section, and use that as our leaving group. And if we do, we see that we wind up forming our acid chloride, and as a byproduct is actually this particular compound, which will actually decompose, don't worry about a mechanism, to give us sulfur dioxide and HCl. Both of these are gases. And so as this reaction runs, actually what we observe is that our byproducts are bubbling out of the reaction as gases, and at the end, we're really just left with a solution of our acid chloride that we can then use as an acid chloride in all kinds of nucleophilic substitution reactions. So that's acid chlorides.